So we are going through introduction of Java. Why Java? So as we discussed, Java is a programming language. So it was originally developed by Sun Microsystems, and then now by James Gosling, and now it is owned by Oracle because Sun Microsystem was sold to Oracle, and then now it is owned by Oracle. So Java is an object-oriented language. So we have OOPS concepts like encapsulation, polymorphism, or inheritance, uh, and then abstraction. All those concepts are from object-oriented programming. So we will see in detail object-oriented programming, but it's an object-oriented language. It's a platform independent, so you can write it in one OS, and then you can also execute it in different OSs. So any different OS, so you can have like take like you can write it on a Mac machine, and then you can also put it into any of the Windows machine, and you can also run that. So it's a simple language because plainly we use English. So most of the content that we use in Java is English. So that's why it's a very simple thing. You just need to understand because mostly the keywords that we use here is if, for, or like any words. So mostly the words, right? Like abstract, encapsulate, or extends, extends, inherits, etc. So all those things are simple English. So that's why it's called simple. Architecture neutral is you can run it on x86, x64. So any of the different kinds of operating systems. It's secure, so you can develop secured websites. Secured stuff using Java. It's portable, which is again moving from one system to another system. Simply, you can just take the code and just move it to another system code and run it. Robust is every time you run the Java code, it will be like giving the same kind of result. Means it doesn't have any defects or anything which will which is error prone. So it's a very robust programming language. So that's why like these are the typical features of Java, which is object oriented programming language. So it's a platform independent, it is simple, it's architectural neutral, secure, portable, and then robust. Okay. So how does Java architecture is? So this is the Java architecture. So you have Java source code. So whatever the Java source code that we have written in the plain English. So we will write in the plain English. So as you know, you have already installed JDK, Java Development Kit. So once we install the Java Development Kit, so what happens is there are a lot of tools that gets downloaded into our system when we install it, like compiler, data, document generator, etc., etc. So whenever you write the code, what happens was the JDK will compile the code. Means the plain English code, whatever you have written, the JDK will compile that code and it will change that code into Java bytecode. So the compiler is the one which will convert. There's a source code that is called plain if conditions or for, so that will be converted to Java bytecode using a tool called compiler. So once that is converted, the Java bytecode is now is again understood by something called JVM, Java Virtual Machine, which has just-in-time compiler. So it will start going through JVM will understand whatever the Java bytecode is, and then it'll convert into machine understandable language, like whatever the machine that you have x86 or whatever it is, it will convert it. So and then it also has the JRE. It's called JRE with the just-in-time compiler and Java runtime environment JRE. So the with just JVM and then the libraries that we have. The libraries is there are a lot of libraries that are written in Java, which we are readily using. Like printing some line, we are using some system.out.println, right? So those things are already present in Java, which are we are using library. So the libraries that we are using and with the Git, the JIT it is called JRE, Java Runtime Environment. Means whenever you want to run the programs, then you have to just use JVM and the JVM and then the libraries. If you want to develop some code, then you have to use JDK. So whenever you want to develop some code, you have to use JDK. And whenever if you want to run the code, then you have to use JRE or JIT. So if you just want to run the programs in somewhere, you have to just install the JRE. And if you want to develop some program somewhere, you have to use JDK. So as I said, Java Development Kit is a program development environment. Writing Java applets means Java small programs, small and applications. It consists of runtime environment that sits on top of operating system. So the runtime environment is nothing but JVM. Okay. So and you can do compiling, debugging, and then running the programs. Everything that you can develop, you can use and develop the JDK. So the JDK is nothing but the compiler tools and all the tools, plus you have JRE. So now you have JDK. The JDK is the tools that we get for the tools are for tools for development. Okay. Plus there is some tool called JRE. So JRE is nothing but Java Runtime Environment. So the JDK is Java Development Kit. So if you want to develop any programs using Java, then you can use Java Development Kit. So now whenever we say JRE consists of two things. One is called JVM, and then Java Virtual Machine. Plus you have Java libraries. So which when in turn whenever you are running the programs, you can use it for development, right? So like system.out or the collections or whatever, there are a lot of libraries that is there. Working with files, etc., is coming from JR. So now internally the JVM has JIT, which is called just-in-time compiler, which will convert the bytecode, whatever the bytecode that we get, and then that will be converted into the machine understandable code. Okay. So now whenever we do a development here, we develop something called dot Java file. So we create a file. So we'll write a Java file and then we'll say dot Java file. So whenever we and then once we write a Java dot file, we'll do a compiling the program. So when we compile the program, so it will convert the program into file dot class. So and then that file dot class is understood by the JIT, and then it will convert into the machine understandable, either zeros and ones or whatever it is. So the machine understandable code. So it will convert that the file dot class. So first file that we'll create is any name with dot Java file. From that, it will whenever it is compiled using the compiler, it will convert that thing into file dot class. And whenever that thing is converted into JIT, it will go and change that file dot class to machine understandable code. Okay. So this is the process that Java follows while while doing the development and then moving that into the execution, and then when we execute the results, whatever it is coming. So all these things will happen using a tool called JDK. So these tools are used for development and also running the program. So if you want to only run the programs, you can use JRE, which consists of JVM and Java libraries. If you want to develop something, then you can use JDK. Okay. Any questions, guys? Raja, any questions?
Good, Bharat.
No, it's
Okay.
good.
Good. Okay. So what is class in Java? So we will go through that, variables, creating an object, etc. So what is class in Java and what is object in Java? So let's create a small program and understand what is class in Java and what is object in Java. Okay. So now a class is like a blueprint. Okay. Blueprint, I can say blueprint or design. So we can call it as a design. So anything pretty much is a blueprint or it's called a design. So then that's called a class. So for example, when I want to design a car, right? So what happens? I'll say, okay. So if I want to have a car, then it should have four tires, and then I'll say, okay, it should have an engine. So it should have something like color, and then it should have some interiors, and then it should have some exteriors, etc., etc., and then whatever. So all the seating types, etc., etc. So we define a prototype of a car, a design of a car. Basically, we want to design a car. So that car should have four tires. That car should have an engine, color, interiors. That should have a body. So basically everything. So we'll design that. So now that we have designed a car, okay, now we can create n number of objects for it. So we have not tell what type of engine we'll use, what type of color we used, what type of body we used. We only told that we'll build a car, and that car will have tires, and then that car will have engine, that car will have color, and then that car will have interiors, and then the body. So we have not told what car has done or what car will do, etc., etc. So as of now, we are just defining a prototype. So we are telling these are the parameters of the type, and then the actions that the car does is you can just say move whatever the forward, uh, or move, or you can just do accelerate. So whenever if you want to do an increase the speed, if you can just say accelerate, so etc., right? So you can just do accelerate, move back, back. When you give it the reverse gear, it will go move back. So etc., etc. These are some of the actions that can be done by the car. These are the some of the items that needs to be placed in the car. So these are called the state, and then these are called the behavior when it goes to the object. But so a car, it's a class which can have a blueprint, and you can define whatever the properties that you wanted to define, and then you can define whatever the actions that you can define. Okay. So and then from this car, once you have a design ready, so you can build 100 cars out of this design. So that is called object. So whenever you build a car, once you have designed a car using that design, right, using that object, you can build hundreds of cars with this design. So you can say, okay, this. But what changes in object is, so the object will have a state, the object will have behavior. Okay, at any point of time, the object will have state and behavior. The state is in the design. We have not said. We have only said there should be a color. We have never said, okay, it should have a red color or green color or what color. So in the state, you can say the current car that I have created can have color is green. So that's the state. So in the current car that you have designed, you can say engine is BMW. So out of 100 cars, you are only defining one car now. Okay, first car that you are designing, it is the blueprint. You know that what is the mandatory things that are required, but from there on, you are just telling what is the current, what is the current behavior of a single car that you are building. So from there, you can say interior, some company, body design, etc. So body, some BMW company model or whatever it is, and then tires, what company you are giving, um, any good company tires. So whatever the different tires that you're giving, etc., etc., you can define a state. You can also tell the behavior of the current car, whether it in the current state, whether it is moving forward or moving backward at any time, right? The car, whatever the car that you have, the green color car or the BMW, whatever it is, either it can move. It's currently in the current state. It can be either moving forward or moving backward or whatever. It'll be doing different things, right? So what is the current behavior of the car? So this is only when you create an object out of this car, that car The object will have all the states and behaviors, not the class. The class is only a prototype. The prototype means you have told that these are the behaviors it can do, these are the these are a couple of states that you can define. From that state, now you are becoming clearly what is the current state that I am trying to build. You are clearly telling it. So here you're not telling, you're just telling, like if you want to buy a house, right? You're just telling, okay, I need to put tiles and I need to put some roof, I need to add some cabinets, etc. But what type of cabinets, everything you have not defined in the class. You told that this is how I can make a house. I need 4 doors, or I need three windows, etc., etc. But you have not defined how, or what. So whenever you are creating an object out of it, you have to clearly mention that, okay, whatever the items that you are taking and whatever you are putting in the object are correctly correctly defined or not. Like color, it has to be green. Engine is this engine. Body is this this. So you can create n number of cars with whatever the design that you have given, with different states and different behaviors, and each car is independent. So means one car, whenever you have built, and if you are building another car, right? The two are independent, because one car will be green and the other car will be red. But it is coming from the same design. Like whenever you see the home, right? You have, say, 2 bedroom home. Each home is different. Each home has its own unique properties. But some might give red color, some might have given blue color. But the design of the home is coming from the same home. So it's only a design. So whatever that you are building, an objects out of that design will have different states and different behaviors, and each object is on independent on its own, and it will have at any point of time different states and different behaviors. Okay, so this is very important that you need to understand in Java when you are going on class and object. A class is a blueprint, or you can call it as a design, and an object is an instance of the class, means any copy of the class. So it's called an instance of the class, or you're making a copy out of that design which you are implementing. And for that copy you're telling what is the state of that copy, what is the behavior of that. So whenever you define these things, you can say that's as an object. So this is a prototype which is called a class, which is a Java class. And once from that prototype, whenever you are making an instance is nothing but a copy. You are making a copy of it, and that copy you're defining what is the state currently, what is the behavior currently. So that makes it as an object. Any questions, guys?
No.
Okay, so let's go to Eclipse and see how we can create class and how we have to define an object. Okay, so now I'm just closing this one. Okay, just give me. So creating a new project, file, new Java project, and I'm saying first class project. So finish. The same way we have defined a car, right? So I can define a car. So before that, there is some concept in Java which is called package. Package is nothing but folder structure. Like if you're arranging your pictures, right? So what you will do? So whenever you are arranging your pictures, you will create folders like event one. So and then you'll copy all the pictures there, and then you will say event two. Um, so event 2, and then you will say, okay, these pictures are related to event 2. And so it means you're aligning your pictures based on your folder structure, event 1, event 2, etc., right? The same way we are also making packages, because you want to align some of the classes which are related, and then making and grouping and putting into one package. So that is nothing but the folder structure that we are creating to maintain our Java classes is nothing but packaging them. So that packages we are creating now. So packaging is nothing but packages are means packages in Java is creating a folder structure. And mostly give packages unique names. Now why? Because there might be a lot of different packages. When I say arc dot common dot util, right? So there are a lot of people in the internet who might have been created, with same package names. So it's very tough to, if you're in the same project, if you're using two or three libraries, it's tough to identify between each other whether they are unique. So for us in testing, it will not be any issue because we are only using internal projects. Whenever we are doing some development, and if the two packages are same, like Selenium, right? If you have given two or three packages names are same, whenever we are calling a class, we don't know uniquely whether we are calling from one package or the second package if the same name of package class is present in two packages. So you will get to understand that, but give unique names to the package, and we give like com dot test dot. That's just a folders. Under the com folder you have a test folder. Under the test folder dot you have something like sample. So means you have a folder, main folder com. Under that you have a test folder. Under that you have a sample folder. So packaging means you are creating a folder structure and one internally to other, and then that packages. Whenever I say full name of a class, right? Com dot test dot sample, which is a package name, dot class name will make your full qualified name of your class name. So you have to give the full name, which is package name with class name. So, but let's see that here. So now I'm just creating a package com dot test dot Java class, so which is our own name. So means it will create a com folder, and then under that it will create a test folder. Under that it will create a Java class folder. So finish. So now we have created a package. So this is the symbol, and then under the package I'm creating a class. So new class. So under the class I'm giving the name of the class. So as Java. Sorry. So we're creating a car class, right? Car class. So finish. So when I have given the car class, I'm defining the so this is now our main class. So I'm defining the properties, the states and behaviors, whatever we have discussed. In the class we don't have states and behaviors, still a prototype, because in the object we'll get it. But I'm just defining now a blind design of a class. So in the car class, as we said, we know that we'll have public. So the types will be integers because we have types, right? So types is 1 2 3 4. So we will discuss these integers and stuff later, but I'm just giving types. So which is integer. Public string. So we'll have string engine name. So what engine we are going to use, whatever the engine we use in objects, that's fine. But we are telling that in a car we need an engine. The same way we are defining public string body. So that body is also some company name or company or type. So but we are telling that car needs body. Okay. So public string interior. So we're telling that okay, we need some interior, but we don't know at this point of time what we'll use. But we are telling that for a car we need interiors. Okay. And then etc etc. So whatever we need to have windows or whatever it is, you can just give all the options which defines a car. Now we can also define the car, what does it can do. So you can also say public void. So it can accelerate. So you can just give your own logic here. So whatever the logic that you wanted to give, so you can give the logic for. So you can break, right? Car you can also do break. So public void break. So what are these? How to do write these functions? What is void? Don't worry about it. We'll cover it later. But just understand that these are some of the functionalities, some of the things that car can do, and these are some of the properties that car can have. So we're making a design. Okay. So in the design, we are telling that. So okay, these are all the properties, and these are all the actions that then car can do. So in the break, so we're just saying sys out. So because break is already a keyword in Java, so it is not using it. So I can say break car, which becomes a unique keyword. So break is already, some of them are reserved words, like public is a reserved word by Java. You cannot use public for tires like variables, right? So you cannot use int. anywhere. You cannot use void for something like that. They are all reserved words for language. So Java uses some words for already for language. Those words you cannot use as for used for names. So like break is one of the reserved word you cannot use for names. So now you're doing a break car, and then you're just saying system.out.println. So now we have created a prototype for the car class. So it has four properties and two actions. One is to accelerate, one is to break car. So this is a class now. So the class is nothing but the design we have created. Now from this design, can we create multiple objects? Yes. So let's create one more class where we can create objects. Can we create in the objects in the same class? We can also do that, but just for convenience, I'm creating it in the different class, which can have a main method. Okay, so let's go and create one more class, and which can say object class, object car. So to start anything in Java, so although we have created car class here, to call this class and do some running of this car class or whatever it is, we need to have a main method which is starting point of Java. So shortcut is main control space. So it will give you different options. Just use main method, public static void main string of args. So now you can use main method. So in the main method, we have to create an object for this car class. In Java, if you want to create an object for the car class, you have to use a new keyword. So car class C1 is equal to new car class. So when you create here, so means you have created a copy of the car class in the memory, and then that car class, whatever the copy that you have created, is now stored in the C1. So you have created a new instance of the class. New instance of the car class means whatever it is present here, right? So this is the car class, and then for this car class you've created a new instance, a new copy of it. So in Java, this is stored in a different memory, and then these ones are stored in different memory. So there's a slight deviation, we can discuss that later. But so whenever you created a new instance of this car class, means this is not the class that you're seeing here. Whenever you're running it, it will make one more copy of this while running, and then it will use that as a unique one. So means from this design it will make one more copy. So and then if you create one more instance, so you are making one more instance, so you can also do that. So you can say car class C1, sorry, so car class C2, so it's equal to new car. So now this is one class, and from that class you created now two cars. So each car can be independent and each car can be on its own. So now if you see C1 dot, you can say body is equal to BMW, and then you can say for C2 dot body is equal to Mercedes. Now each object is independent on its own or not. So now C1 car is a different car and C2 car is a different car. How do we know it? So once we have assigned C1, when if it is not a same car, this will get overridden to the body, right? So these two are different or not. If you want to understand, then I'm trying to print C1 after assigning to C2. So here I'm just saying sysout control space, and then I'm just writing C1 dot. So I'm just finding out what is the body currently. So if it is Mercedes, means they are still same. If it is giving you BMW, then it is there, it's different, because now this is a different car, this is a different car. So let's find out first C1, and then let's see what's there in the C2. So when I run the code, so if you see here, it's just BMW, because although we have created a different object called C2, C2 is independent. It's not the same object. So we have created two copies of the car class, which is named under C1 and C2. So in the memory, it created a class, and then it is stored in C1 now. and in the memory it created another car class and it is stored in C2 now. And then if I say C1 dot body, it is getting whatever we have assigned for the car one. And now if I want C2 dot body, so then it will get me C2 dot body. When I say it's car 2, so just to differentiate, this is car 1. So if you see here, car 1 is equal to BMW, car 2 is equal to Mercedes. Means, so it is having two objects now. So whatever we have assigned to car 1, it is showing for car 1. So whatever you have assigned for car 2, it is showing for car 2. So basically, so from one prototype, which is called class, we can generate n number of objects. So that n number of objects here is like for a car class, we have created C1 as one object and C2 as another object, and that we have instantiated here. So because in the main method now we are creating two objects, we are assigning some properties for that object in the runtime, and then we are trying to view that whether they are properly assigned or not. So we can see it by looking at what is there that is present in C1, and then we are looking at what is there present in the C2. So any questions?
Yes, I have some questions.
Mm-hmm.
I didn't understand why we are using the capital in between the car and the class. We have to use the capitals every time.
No, that's
I
we
mean,
used to
car
use it for
class.
the car, so we can use capital C because it's Java insists to use, I believe, mm, it is just a camel casing, I believe. If not, I can
Okay.
just correct myself. So they have, I mean, it's an symbol that we follow for Java for all the classes. Every letter that we start, like car, C should
With
be capital. C in the class, C should be capital. If you are using a
okay.
variables, for the first letter would be small, followed by every capital letter in the next from next. So it's
Okay.
just a convention. I mean, it's not a mandatory convention, but it's just a convention.
Connection. And another one next to the main string. Why we are using that box, the square box?
No, that we'll discuss later. I'll just tell you.
Okay.
You'll understand it when we, do the classes.
Okay. Even I don't know what is ARGS means.
Just a variable name. It's just a name. It's
Okay.
a string array with arguments, but you will understand when we start
Oh,
array.
okay. Okay. Just one thing.
So leave this. I'm just putting understanding whether you have understood what is Java class and what is an object and why there are two objects that we have created and whether they are independent or not.
Yes. Yes. Yeah. Okay.
You will understand everything here. What is class, public, static, void, everything you'll understand, but not immediately. So it'll take some
Yeah.
time
Yeah.
because we need to go through all the classes. So
Okay.
everything that you see at the end of the day, somewhere you don't understand, you can ask me, but it'll take some time because we are going through the classes, right?
Yes. Yes. That's true.
Yeah. Good. Any questions? Kavita, any questions? Raja?
Okay.
Okay. Let's see what is the folder structure that we have seen, right? We said package is a folder structure, and then we have seen a lot of things. So let's go and see in the project how it is. Okay. So now this is the package that we have created. I mean the project that we have created. So in the project we have two folders. So one is called the bin folder. This comes after the execution of the program, and then after which is called compiled ones. The other one has source code. The source is like whatever we have written, the plain English one. So that's the same source that you're seeing here, the same source that we're seeing here. This is your project, the first class project. So all whatever we have written is here. Okay. Under the source, if you see, now we have created a package called com.test.java class. So it created a com folder. Under that, it created a test folder. Under that, it created a Java class folder. Under the Java class folder, it has created .java files, as discussed before in the notepad, right? When I was writing, so it will create file.java. So if you see the name of the class that is given here, whatever the name of the class .java, so it is given here as the same. And if you see here, the name of the class here is same. So the name of the class here, the file name, the name here in the class will be every time same. Okay. And let me do so. And then if you see here, I'll go back. So now Java class, under the Java class you have car class and then object car. So the same thing, the one that we have seen here. And if I just go back, if I go to the bin folder, then com, same thing, it is created test Java class, but hit here dot class files. So when I say dot class files, they are all the after the compiler compiled the program, the same dot Java files were converted into the dot class files. So now this can be understood by JRE. From now on, you can just leave the source code and you can use these classes until or unless you need modifications. Then you have to use .java files. But these are not understandable if you open also. Just using anything like Notepad or whatever. If you just try to open, it'll not. It'll not. You cannot see anything basically. So here there is no way also to open. But if you just even open, I'll just use notes. No, it did not open, but even if you see, right, in your missions, if you can see, so just go and see it, but you can see a lot of symbols and stuff, which is not really related. Okay. So and then these dot class files are just, you can just move these dot files class files from one machine to another machine, and you without, it's like mission independent, you can just run on one machine to other machine. These are all portable, you can just move them directly. So all these things can be possible. Whatever we discuss, the properties are, everything is possible in Java. So again, so package is a folder structure. As we see here, it's just a folder structure, whatever the folders that we have created. So com is one folder, under the test is one folder, and Java class is one folder. Under that there are two classes. Car class is one class, and then object car is one class. We have two classes. So whenever we went and compiled the program, means whenever we run the program or whenever we debug the program, means when I run the program, it's now executing, right? So whenever we executed the program, it compiled the program, and then that compiled program, whenever you do that, it will be present. It will just create a bin folder and it will just add the same structure, com, test, and then the Java class, and then it will create dot class files. Instead of dot Java files, it created dot class files. Means the JDK has converted the plain English ones into the JRE ones, which are now bytecode ones. So as we've seen in the previous diagram, so it just moved from the .java files to .class files, and now they are stored in the .class files. So now this is understandable by JVM, and then it converted into machine understandable language, and then we will see the output. So this is how it works. So and this is a class, whatever we have discussed, and then this is a this is an instance of it which has a main method, and you have created multiple instances of the same car class which are nothing but the copies of the car class, and then you have created, and then you have checked whether they are independent or not. So by checking whether one object is not overriding on the other object, means c1 dot body equal to BMW, it's not overriding here. C2 is a different object and C1 is a different object, and then we have checked whether they are printing it properly or not. It's happening. So a variable is something in Java which can store some values. So here it's storing the complete class. So C1 is a variable now, which is called instance variable because it's making a copy of the class. So once it makes a copy of the whole class, it's now storing the whole content of that copy into one variable called C1. The same way C2 also, the whole copy of the second class, whenever you make the copy and then it's stored in C2 now. So when I say C2, it's a reference of the car class, and when I say C2 dot body, it has made another copy, right? C2 dot body is whatever the body that you have assigned. C2 dot interior is whatever the interior that you have assigned. C2 dot tires is the same thing. So even it applies to the C1 also in the same procedure. When I say C1 dot something, then it is C1 is another class which has tires, engine, body, and interior. So now C1 is one variable and C2 is one variable. They both are called instance variable because they are maintaining the whole content of a class. So because you made a copy of the class and that class copy is now stored in C1 and that class copy is made in C2. So the variables that we see here is instance variables. Um, so that's about class and object. A class is a blueprint. So as again we discussed, so a class will have all the attributes and then all the actions. An object will have state and behavior. The state is nothing but whatever the properties that we can define is the state, and then whatever the actions, the functions that we have, C1 dot accelerate, those things are behaviors. So a class will have state and behavior, so nothing but properties and actions. So you can define any different states. So each individual object can be in a separate state and separate behavior at any single point of time. So same thing with class 2 also. At any point of time, it can have a different behavior and different state. So which are independent between two different objects. Any questions?
I think it's
Uh,
clear.
Pardon?
why do
Yeah, I cannot hear your voice, Raja.
okay? Why do we here calling two classes here, like car class and object car class, and why do we declare all the same states and behaviors in only car class?
It's the same thing, right? If you say human, right? So I mean, each one is same, right? Each person is same. We call them like different objects because so we are coming from the same prototype, like human, whatever the structure it is. So each one is again different. We have a different name. I have a different name. But how we are created? We are created from the same human prototype called human prototype. I'm just giving an example to funny to remember, but I'm saying so. And then when I talk about two different persons, they two are both are independent. I mean, the one at this point of time, as a person, I'm speaking as an object, which is called C1. Let's say consider I'm C1. So you as the same
No,
type C2.
uh,
Pardon?
actually, I'm not asking about states and behaviors. I'm asking about why we are calling two classes, car class and object car class. Here
See,
we are calling two classes, right? Class object car class, right?
car class is something which we have created the full prototype. Object car class, why we are doing is because just because we have to create new instances, I have just used object car class as another class which you can create instances. So you can also call main method, which means you just need to start creating objects and just showing it. So whenever, until or unless you create an object, right, the car class is anyway not useful because it's still in the design, it nowhere used. So I created another class just to use car class, that's it.
Okay, okay, I'm good. I just okay.
Okay.
Yeah,
But you understood what is an object and class, right? So
yeah, yeah, I do.
okay, cool. Any questions, guys? Any other questions?
No.
Okay, I'll stop this I mean, sorry, I stop this class here, and then we'll see tomorrow what is variables, what is how to declare variables, what are different types of data types that we have, etc., etc. So just go through this. I'll just upload this video also. Just go through this and try to create a class, and then try to create objects and try to run and see whether you're able to create multiple instances of the classes. And we'll see tomorrow variables and then how to declare all the Java, different concepts in Java, etc. Okay.
Bharat, do you have any small notes on this?
Yeah. So in the same here, right? As I told, I'll just upload my
Oh,
presentation.
it's in the, okay, okay. We
Yeah.
can go there and read, right?
Yeah, that's what.
Yeah, just want to know, read some about the definitions, what is there.
No, everything is here. If you just go here, everything is in this website. So if you go to I'll just change this little bit, but if you go to Java basics and you have variables, conditions, Java basics, etc., everything is
Oh,
here. You
okay,
can just go
okay.
and read also here. What is everything?
Yeah.
What is difference? What you want to read? Everything is here. Okay.
Mm-hmm. Yeah, okay.
And then the video will be also here. So you
How,
can just go.
where is the videos? Where should I go for videos?
You go to the learn and then videos.
Oh, okay,
Yeah.
okay,
Yeah, you don't need to write anything. You'll just have everything here.
okay.
Okay.
Yeah, thank you so much.
Yeah. Okay, guys. We'll see. We'll meet tomorrow, same time. Okay, 9 o'clock.
Thank you, bye.
Okay.